So thanks for having me here, and definitely thanks for AWS and the Daft and Snowflake guys to organize the event. It's definitely a great event, right? And today I'll be talking about how we implemented the Iceberg connector in Rust. And if you were in the first half of the meetup, you got to learn how the AWS guys will implement their Iceberg support, and also from the Daft, they mentioned how they build something that can allow you to run distributed computation on Iceberg, right? But today I'll be talking more about, it's just more like a story, and it's not for technical details, right? If you could not really follow the technical part, well, then probably you will love my talk because it's non-technical. So before I start the talk, I have to mention that all the credit goes to the Apache Iceberg community. I do not really write any single line of code, and it's definitely the credit should not give to me, right? And not any party I represent, right? So all the credit goes to the Apache Iceberg community. So my name is Yingjun Wu, and I'm a founder of Rising Wave Labs. Basically, we do stream processing, we do data ingestion, all these kind of stuff. And now today we have a lot of AWS guys, right, and AWS employees. And I also came from AWS, and I used to work in AWS Redshift team. Before that, I was at IBM Research Armadan, so basically South San Jose. And I'm up to my PhD in stream processing and database systems. About one slide about what a Rising Wave is. We are basically a distributed SQL streaming database system. And best in class, we try to deliver the best in class stream processing, management, and analytics capabilities. And it's open source on the Apache 2.0 license, right? So what we can do? So basically, let's think about if you have data coming from, let's say, Kafka, coming from, let's say, Postgres CDC, MySQL CDC, or come from let's say, just the S3, right? We can help you to continuously ingest the data, do all kinds of computation, do the data serving, and or probably deliver data into your lake house. And then, okay, so because this talk is definitely not about for Rising Wave, but for another way to think about what a Rising Wave is, how we compare with some other systems, right? Most of our 70% of our users compare Rising Wave with, probably Flink, probably KCDB, probably Spark Streaming, Kafka Streams. So basically you understand what we do, right? Basically it's stream processing. And another 30% of the customers will use this Rising Wave as materialized view services. Let's say that you have a Postgres, if you have, let's say, a MySQL, or if you have MongoDB, you really want to build a materialized view, right? So real-time materialized view, you think that, okay, my materialized view is super slow, or you think that, okay, probably I want to build something like cascading materialized views, then, or probably build a data product or data mesh, then probably Rising Wave is the way to go. And then now it goes back to Iceberg. What do we do with Iceberg? So people use Iceberg because, I actually did a survey on the community why people move to Iceberg. Because, most of our users will say that, not our users, the Iceberg users will say that they are afraid of vendor lock-in, right? Well, they probably they are afraid of, let's say, Databricks or Snowflake, or probably AWS will charge them tons of money, right, every single year. So that's what if they adopt the Iceberg, then they essentially have the leverage to bargain with the vendor, right? So that's true. And I think that's probably just one of the reasons. The other reason is that Iceberg is, super easy to adopt because it's just based on top of Parquet, right? So it's just a layer on top of Parquet. And as long as you have your Parquet files stored in S3, you can just add a layer on top of it, and then now it becomes a data lake. And then you can use any single language, any kind of language, like no matter whether it's Python or Java or whatever, or SQL, or any query engines like Snowflake, Trino, whatever, right, to query the system. That's why Iceberg is so popular. But are there any challenges using Iceberg? What we found here is that essentially the ingestion is always pain, right? So how do we ingest the data from MongoDB, Kafka, Postgres, CDC, or let's say S3? Many people were just let's say use Spark, right? Definitely we can use Spark, and probably we can also use the Airflow to orchestrate job, right? To periodically or to dump the data from your data services into Iceberg every single day. You can definitely do that, and yeah. But for as long as you can see, well, I mean, as long as you have experience using Spark or if you're using some other big data systems, you will find that okay, it's definitely a pain, right? So how do we do that? I mean, definitely we want to have something that is simple, and it definitely can ingest both batch data and streaming data, and it can work with most of the modern data systems, right? No matter whether it's Postgres or MongoDB or MySQL or let's say Kafka, Repanda or Pulsar, right? Or you definitely want to ingest data from anywhere to your lakehouse, to your data lake, because right, it's a data lake, right? Well, that is the endpoint, right? And definitely you also want to support schema evolution, because we know that well, your data may change, well, your operational data team may change your schema, right? Well, probably they change add a column or delete a column, and you don't really want to do the schema change in your data lake well manually, right? You probably want to have a system that can automatically do the schema evolution for you, right? And probably you also want to do the pre-processing, right, to remove the PI information from the data, from your data, right, from your operational data, right, or think about the GDPR, right, for how to ingest your European data into your data lake. You probably really want to remove the PI, right, and you also want to have a great observability of the data. You actually want to not just write the data, but also read the data, right? So you don't really want to just say that okay, I read the data, but I never know okay I never know what I wrote, and you just want to use one single system to do that, right? And to check just check what you wrote, right? So, I mean, if you want to find a system that can satisfy all these kind of like combinations, all these kind of like features, then potentially you are thinking about okay, probably Spark or probably Flink. But I just mentioned, I mean, as long as you have experience using systems like this, well, you know how challenging it could be, right? You probably also need to, or probably you have to reuse, well, let's say AWS or EMR, right? But well, what Writing Wave does is that well, it's pretty simple. That is, well, I mean, in the data lake, well, with the Iceberg ecosystem, what it does, well, it's really simple. That is, it provides a Postgres experience to interact with your data lake. What it means that well, how to create a table in Iceberg. Many people probably will use Athena, right? Well, probably manually use Spark, right, to write a Spark job, right? Well, write a SQL query in Spark, right? In Writing Wave, you can just like create a table in Iceberg just using the create a table, the Postgres statement, right? And how to ingest the data into Iceberg. Same thing. I mean, you don't need to write a lot of like jobs, right? So the only thing you need to write is like insert data into something, right? Or you can definitely build your pipeline for sure. Okay, and that's all about what we have already done. But what's the technical challenge here? Writing Wave is essentially building Rust. I know that's what Daft also building Rust, right? And many other newly built systems are also in Rust, right? Where there are a bunch of like things like, give me some names for probably Data Fusion. Is Data Fusion building Rust? Yeah, Data Fusion, right? And so a lot of like newly built systems are actually in Rust. And Iceberg, but unfortunately, it's probably not unfortunately, but well, I mean, historically, the Iceberg interface was built in Java. Everyone knows that. And okay, performance is definitely a big issue because, well, not because well, I don't really want to talk a lot about Java. Okay, Java is great, but the challenge here is that, if you want to interact with a Java system, I mean Rust system using let's say a Java API, right, a Java interface, it's always slow, right, and definitely development isn't easy, right? So because your Rust developers have to use a Java interface. Think about what they were thinking, right? So definitely that will be very, very challenging. So we think about, okay, how can we do that? Essentially, the first version of Rising Wave, the Iceberg integration was built on top of, like, say, the original Iceberg interface. But we found that was super, super difficult, challenging for us to debug, and super, super difficult, challenging for us to improve the performance. So that's why we think about, but we checked some other projects, like some other interfaces, some other data projects like Delta. They essentially have a thing called Delta RS, and they told me that's why it was contributed by the community member. And I know the guy is called Yingjun, right? And he actually wrote a Rust interface and contributed to the Delta community. And it's great. It works great, and it was definitely we have already integrated, used this library to integrate Rising Wave with Delta. It's great. So we think that whether we can build the exact same thing for the Iceberg. So, so the first guy that created a repository was named Yingjun Wu, and from the Databand, which is a database startup. And he actually initiated the project, and the code name was not called Iceberg RS. It was originally called Ice Lake, and for all kinds of reasons. The first one, that's what I mean, it's a new project, and the Apache Foundation probably doesn't really like it, right? So because you are not mature enough, right? You actually have to build something before contributing to the Iceberg community, to the Apache community. And second thing here, that's what I mean. Originally, they actually plan to implement an open lake layer that works with any data table format. That means that Ice Lake originally have the ambition that can work with all these three or even more data lake formats, right? Like Hudi, Iceberg, and the Delta. But they decided to not just focus on so many things, but they just want to focus on only one thing, that is Iceberg. And why? Because the community asked for that. Because for Delta, they have already had the Delta RS. Hudi guys will say they probably want to build their own Hudi RS stuff. So, but for Iceberg, there are definitely huge demand, not just because no one builds that, but also because definitely more, and we find that essentially more than half of the people or lakehouse users actually want to use Iceberg. That's why Ice Lake decided to focus on Iceberg. And the implementation of the Iceberg. So, yeah, don't be so nervous. I will not talk about the implementation of the Iceberg because, right, as I just checked, but it's so boring to expand the implementation details. But if I can summarize for the implementation of Iceberg, I can go with these 3 lines. The first one is that we just follow the official Iceberg implementation, and everyone can have access to the Iceberg spec, right? We just follow the Iceberg implementation. And second one is that it essentially supports spec v2. It is very important because we don't really support the v3 yet. And for V1, it starts with V1, but V2 is released, and it definitely have a pretty good support with delete, which is pretty important, right? Which is pretty important. So that's why it essentially supports V2. And the third thing here that you probably need to pay attention to, that's why it's essentially 3 times faster compared to Iceberg Java. As long as you are a Raspberry-based project, right? You don't need to work with a Java API. You can just work with the native Iceberg integration, the interface, Raspberry interface. So then they decided to think about, okay, now we have the Ice Lake. What's next? Can we be part of the Iceberg community? And the first guy that initiated the discussion was actually Brian. And he mentioned that, it was a great thing to start a Rust projects that in the official Apache Iceberg repository that we can work all together. That's his credit, right? So that's why these guys were donated for the Ice Lake project into the Apache Foundation and became now it's called the Apache Iceberg Rust project. So today's Rising Wave plus Iceberg. Now with all the credits go to the Iceberg community. With the Iceberg Rust project, now we can operate on Iceberg using PostgreSQL. That's Rising Wave's credit. Okay, and but what I mean with the Iceberg interface, we can have high performance read and write. I will show you a number later. And it supports scanning deletes, which is pretty important because if you check some of the existing engines in the market, you will find that if they are probably building some other languages, probably C++ or some other language, you'll find that they only support scanning append-only tables. But with this Iceberg interface, with this Iceberg Rust interface, we can essentially scan the deletes data. And regarding performance, well, I'm not trying to, do anything like benchmarking, okay? But I just want to give you some sense of improvement, okay, for sure, yeah. So, we can just compare with ourselves, right? Well, our Rising Wave has its native row level store. And we tested Iceberg Rust in two settings. One is the main I/O setting, and the other one is the S3 setting. Compare with our own row store. Row store is stored in main I/O, but it cannot be. It probably takes too long to run the S3 test. But yeah, anyways, I don't know the reason why the data is missing. But anyways, so you can see that we dropped the latency from 30 seconds to just 110 milliseconds. It's a huge improvement, right, compared to the row store, scanning a row store. It's probably 100 times, right? Is it 100 times? Yeah, probably, yeah, more than 100 times. And comparing to ClickHouse and DuckDB, two of the pretty famous query engines on top of Iceberg, right? You can see that the performance is pretty close, and it's actually to some extent, in some cases, in both cases, it's actually faster than DuckDB. I'm not trying to do anything like benchmarking, but you can definitely test. And it's just a pretty small data set, where it's just let's say a 7.5 gigabyte and a 20 gigabyte data set in main I/O and in S3. But as you can see, with this Iceberg Rust, we do have a huge performance improvements. And my wish list. Well, I didn't really show my real wish list in this slide, but my wish list to Iceberg Rust is definitely to support Iceberg spec v3, right? Actually, v3 spec was just closed. Well, the issue was just closed probably last week. No, not last month, right? Probably last month, or probably 2 months ago. And it will have enhanced support for deletes, but definitely more than just the deletes. Well, it also have a proposal about the materialized views to support native materialized views, right? So if you have ever used Rust, well, it was not listed here, but if you have ever used Rust, you know, used Iceberg, you know that Iceberg doesn't really support CDC, right? Native CDC, which means that if you want to do ETL on top of, say, Iceberg, it will be very challenging. I hope that's probably there's something could be added in the Iceberg community, not just the Iceberg Rust, but the Iceberg community. And definitely if you build your product on top of using Rust, definitely consider using the Iceberg Rust products, because it's super solid, and it definitely gives you huge performance improvement. Yeah, that's my talk, and lots of things that's what I want to mention. There are good things and bad things about donating to the project, to the Iceberg community. That is your code will be reviewed, right? The good thing here, that's where your code will be reviewed, and the bad thing here, that's where your code will be reviewed, which means that closing a PR could probably take a longer time. So essentially, there are some. I showed you numbers, but I have to admit that there are some code was still based on the Ice Lake project. So because there are some PRs that have not been closed in the Iceberg repository. So if you have have some questions about what kind of features, any missing features, something like that, talk to me, and probably we can see whether we can close the issues as soon as possible. Yeah. All right. Thanks.